My name is B. Ravindhar, Assistant Professor, Department of Electrical Electronic Engineering, BVRIT Narsapur. Today I am dealing on Power System 2. The topic is underground cables. So you can see here underground cables we can lay in substations or where there is a connection of these transformers and to the transmission lines. There it is required the underground cables. So you can see here the different underground cables that are laying in the field. And in this particular content, I can explain about the types of underground cables and its construction, and types of insulating material, and calculation of insulation resistance and stress in the insulators, and capacitance of single and three core cable you can see, and also the grading of the cable, that is capacitance grading and intersheath grading is one of the topic we can discuss in this content. So you can see that the parts of this underground cables, it is having conductor. First part it is having conductor. Next one is insulator. After the insulator we can lay a metallic sheath. Then it is having bedding. Next is having armoring. Next it is having serving. So these are the layer in case of underground cable. First it is having the conductor, then it is insulators, then it is having metallic sheath, then it is bedding and armoring and serving. So you can see the conductor, insulators, metallic sheath, bedding and armoring and serving. So we can easily remember these layers like CO in the first, it is CO, IN in insulators, ME and SH. So you can see the coin mesh bars, coin mesh bars. So you can remember like this: coin, CO means it is a conductor, insulator, metallic sheath, B means bedding, A means armoring and serving. So in the objective exam, he may ask you that what is the layer after that bedding, or maybe before the serving, what will be the layer. So like that he can ask in the exam. So you can remember all these layers. After the conductor, what will be there, and after the metallic sheath, what will be there. Like that we need to remember as coin mesh bars. So first one is the conductor. What we can see that conductor, we can use either a copper or aluminum conductor will be there, and the purpose is to carry the current. And the cable may consist, it may be a 1, 2 or 3 or 4 conductors in a particular cable it may be having, and sufficient flexibility of the conductors are used in standard form. Next one is we are having the insulator. Next layer is insulator. So this insulator purpose is the material which may be rubber, vulcanized rubber, PVC or impregnated paper. So these are the material we are using to construct the insulator. Then it is the purpose is to prevent the leakage current from the conductor to the ground. So how to prevent the current which is flowing from the conductor to ground. And type and thickness of this insulation depend upon the voltage levels. So the insulator is always depend on the voltage levels, the current carrying capacity, that is the current depend on the size of the conductor. And next part we are having the metallic part. In this metallic part we are having either a lead or aluminum can be used, and purpose is to prevent the entry of moisture. So this metallic sheath they can use for entry of moisture or gases, some other liquids into the insulation from the earth surface. And as the cable is placed under the ground, soil may present moisture, gases and some other liquids. Next part we are having bedding. So it may be made up of jute or hasten tape, and the purpose is to reduce the mechanical stress externally on the surface of the cable. So to reduce the mechanical stress, they can use this bedding is another layer, and to protect the metallic sheath from the corrosion or some mechanical injuries, and then we are using a bedding is provided for that. Next one is armoring. So the armoring can be made with this galvanized steel wire or a steel tape. So it is having a steel wire or steel tape can be constructed, and the purpose is to protect the cable against mechanical injuries. So during the laying of the some work near to the cable, it may damage your cable. So you have to protect from this mechanical injuries they can provide, and also used to protect the cable from mechanical injuries while handling. So while handling, you need to put the cable at that particular location, it may be get damaged. We need to protect from that. This armoring is provided. Next layer is having serving. So purpose of this serving is, and the material we are using is jute, and the purpose is to protect from the armoring from the atmospheric conditions. So from the atmospheric conditions, we need to protect from that. The servicing is another layer we are using. So this insulating material properties, what type of insulating material we need to select for a insulation, with that what are the properties it is required for a underground cable. One is the material is highly resistive. So high resistive material it is required in terms of mega ohms. Next one is high dielectric strength in kV per centimeter. So high dielectric strength is required. And next is high mechanical strength. So the material should be high mechanically strength. Next, low permittivity and low thermal conductivity. Thermally it should not conduct, and low water absorptions and inflammable, and high chemical stability, means with respect to some component it should not react. Next is it is having high viscosity to impregnated temperature and high tensile strength. So strength should be high. Next is high plasticity. So these are the properties we require for a selection of a insulating material. So insulation material for the cable, we can use the rubber. We can see that rubber how it can be naturally we can take from the tree. So the rubber it can be obtained from the milk sap of tropical tree or the from oil products. So basically we can see near to this Kerala regions or maybe in the Jammu Kashmir regions, we can see these trees, and from the tree they can collect that rubber, means that rubber, and they can go for the processing. Next is dielectric strength of this rubber is 30 kV per mm, and insulation resistance is 10 into 10 to the power of e power 17 ohm centimeter, and relative permittivity varies between 2 to 3. And they readily absorb the moisture and soft liable to damage due to the rough handling and gases when exposed to the light. Next, you can see the maximum safe temperature is very low, about 38 degrees centigrade. And insulating material for cable, you can see that vulcanized rubber, another type of rubber we are having, vulcanized rubber. It may be pure rubber, and it is having zinc oxide. Then it is added with a red lead, and it is heated up to 150 degrees centigrade. Then vulcanized Indian rubber can be, the vulcanized rubber can be made. So means we are having pure rubber, then zinc oxide, then it is having a red lead. Then these are the like a powder, and it can be made into heat up to a 150 degrees centigrade. Then we can make this vulcanized Indian rubber. And it is having high mechanical strength, and this for low and moderate voltage cables we can recommend this vulcanized Indian rubbers. And we can see that the scapular reacts quickly with the copper. Next is impregnated paper, another type of material we are using. Impregnated paper, it is a pulped paper, and it is added with naphthalic acid, and then it is paraffic material. Then impregnated paper can be constructed. And this particular impregnated paper is having high insulation resistance and low capacitance, and dielectric strength is 4 kV per mm, and the low cost. Disadvantage of this one is hygroscopic, and this reason the paper insulation is always provided protective covering. So it may be hygroscopic, means it, with respect to water it may be poor. So that is a disadvantage of this impregnated paper. Then we required some protective covering for this impregnated paper. Next is varnished cambric. So it is made from the cotton cloth. Then it is added with the varnish, impregnated and coated. So varnish is coated on that particular cotton cloth. Then this varnish cambric can be made, and it is having high dielectric strength in kV per centimeter, and permittivity is 2.5 to 3.8. A disadvantage of this, again, it is having a hygroscopic, and so needs some protection. Next is polyvinyl chloride PVC cables, that is good dielectric strength kV per centimeter and high insulation resistance, and up to the voltage 33 kV. Up to 33 kV we can recommend this PV cable, and high melting temperature. Disadvantage is not so good for mechanical properties as those as rubber. With respect to rubber, if you compare, this PVC cable may not be mechanically good strength. And inert to the oxygen, almost inert to the many alkalines and acids. Next, another cable we are having XLPV cable, cross-linked polyethylene cable. So either they can use mostly in PVC cables or maybe XLPV cables in our underground cables. So XLPV cable is material temperature range beyond 250 to 300 degrees centigrade, and good insulation property and low dielectric constant and having high mechanical strength. Next is light in weight. The weight with respect to also it is very light, and low water absorption, and conductor temperature is 90 degrees to 250 degrees. So there is a variation of temperature variation, and this XLPV cable, cross-linked polyethylene cable, is recommended greater than 66 kV lines. And this classification of this cable, so mostly practically we can see the cable may be PVC or XLPV cables. So this PVC cable we can recommend up less than 33 kV, and more than 66 kV we can see that XLPV cables. And next, that is we can see in the transformers where the transmission line, these substations and this your underground cables, they need to connect in the substations. And classification of the cable, it maybe depends on the insulating material, or maybe depend on the voltage, or maybe number of core. So the cables can be classified based on the insulating material or voltage or number of cores. So based on the operating voltage, we have the low tension cables, LT cables, and it may be up to 1000 volts. High tension cable, HT cables, and it is up to 11 kV. Third one is super tension ST cables, and it is from 22 kV to 33 kV. Fourth one is extra high tension cables. It is from 33 kV to 66 kV, and extra super voltage cable, it is beyond 132 kV cables. So based on the operating voltage, we can classify the voltage, this cable, LT cable, HT cable, or ST cable, or HT cable, or extra super voltage cable based on the voltage. Next, we are having based on the number of core, it may be a single core cable, or maybe a 2 core cable, or it may be a 3 core and 3.5 core cables, and 4 core cables. So like that we are having different type of cables based on the number of cores. Single core low tension cables, single core, and LT cables. So you can see that in the single core LT cable, we have the first one is the conductor. Next, after this we have the layer is having a impregnated paper, then we are having a this lead sheath, then it is having serving. So these are the parts in case of single core LT cable. And this one is having stress developed in the cable for a low voltage up to 6600 volts is a small. And this cable for 3-phase service deliver 3-phase power, and 3 core cable or 3 single core cable may be used. So if you want to supply the more power, instead of going in a single core RYB phases, they can be supply 3 different cables. R phase is the one cable, Y phase, B phase, like that we need to, if there is required the high power transmission, then this 3 separate cable is required. So up to 66 kV, the 3 core cable multi-core construction is preferred due to the economic reason. So all these RYB phases can be made in a single core. So that is a up to 66 kV 3 core cable can be recommended. Beyond 66 kV single core cable means only one cable is there, that is you say it is one core RYB. So separate cable will be there. In case of beyond 66 kV cable, we can recommend like this, up to 66 kV, this RYB. All these phases can be placed in a single core. So that is your up to 66 cable, we can recommend it as this 3 core cable, and single core cable is recommended for beyond 66 kV transmission line. Next is up to 11 kV 3-phase services, we can say up to 11 kV screened cables, and from 22 to 66 kV pressure cables, beyond 66 kV cables, First one is belted cable. So we are having belted cables. And what is this belted cable? So belted cable, you can see that it is having the cores. So these are the core. We are having, say, these are the cores. And between these two cores, we are having this insulator. Here it is provided a insulation. Between these two, it is having insulation. Then it is having paper belt. All these three faces, RV faces, can be belted as a one belted cable will be there, paper belt. After this, we are having this belted, the gap is filled with the fibrous insulating material, that is your jute. Then it is having lead sheath. So this part is a lead sheath. Then we are having thick insulation between this conductor and sheath. So between this belted cable and sheath, we have the another insulation. So that is about the belted cable. Belted cable means RYB faces. This is R phase, Y phase and B phase. Three phases will be belted. Like this, it is a belt will be there. And all these three phases will be having a lead sheath insulation, and this arrangement will be there in case of belted cable. So this belted cable is suitable only for low and medium voltages. Electrostatic stress is more or less radial. So the electrostatic stress is radial, that is across the insulation. So you can see it is the axial and it is a tangential. So actually it is there and it is a tangential stress. Then it is having radial means like this. So means the current is flowing like this, and at radially it is outward. The stress will be there at outward. So it is the stress throughout the insulation. So tangential stress, the impregnated for high voltage beyond 22 kV, we can recommend, and causes local heating resulting in the risk of breakdown of the insulation at any moment. So the stress acted the layer of this paper insulator set up a leakage current along the layer of the paper insulation. In order to overcome this difficulty, screened cables are used where the leakage currents are conducted to earth through a metallic screen. So we are having this metallic screen. Next we can recommend it as a screened cables where the leakage currents are conducted to the earth through this metallic screens. So next one is we can see about screened cables. One is H type cable, another is SL type of cable. So this H type of cable is recommended up to 33 kV and SL type is used up to 66 kV. And this H type of cable, you can see here, these are the conductors, these are conductors, these are conductors, R, Y, B phases, three phases. We can see here it is having, say, R phase, Y phase and B phase. And all these phases, each phase, it is having their own metallic screen and paper insulation. So before that we are having RYB phases and there is a belted screen. After that there is a metallic screen. Now the metallic screen is there for every phase. Then it is having paper in this particular conducting belt. So three phases we are having conducting belt. After that it is having a lead sheath. Then it is having a bedding. Next is armoring. Next it is serving. So like that, this is the H type of cable, and conducting belt, either a copper or woven fabric tape is wrapped around these three core cables. No insulating belt. The electrical stress are purely radial and consequently dielectric stress are reduced. So here the stress whatever it developed, it will be radial like this, and now it is conducted to this particular screen cable, then it will be less. And advantage of this is positively of air pockets or voids in this dielectric is eliminated and metallic screen is increased. The heat dissipation power of this cable gets increased. Next one is SL type of cable. So we have this is the conductors. These are the RYB phases. Then it is having lead covering. Then it is having cotton tape. Then armoring. Next it is serving. So it is basically H type of cable, but the screen around each core insulation is covered by its own lead sheet. There is a screen around the each face. So that is a different in this. There is no overall lead sheet, but only armoring and servings are provided. Orally we have this lead sheet. What is here we can see that orally we are having lead sheet. Armoring and serving is there, but not lead sheet. And advantage of this SL type of cable is the separate sheaths minimize the possibility of core to core breakdown. So it can be avoid the core to core breakdown, and bedding of the cable becomes easily due to the elimination of overall lead sheath. Disadvantage of this one is there is a 3 lead sheaths of SL cables are much thinner than single sheath of H type cable, therefore call for greater care in manufacture. So limitation of this solid type SL type of cable. So load gets increases, the conductor temperature increases, stretches the lead sheath which may gets damaged. So load get decreases, conductor cools and partial vacuum is formed within the cable and the sheath, and if the pinholes are present in the lead sheath and moisture air may be drawn into the cable. There is a moisture air may be entered. So voids are always present in the insulation of cable, different expansion, contraction of the sheath and impregnated compound. Next cable we are having is pressure cable. So this pressure cable, it may be having oil filled cables. Next is gas pressure cable. So this greater than 66 kV up to 230 kV. So this oil filled cable can be recommended greater than 66 kV and up to this 230 kV. This pressure cable can be used. And oil filled cable, it may be a single core conductor channel, single core sheath channel, and 3 core filler space channel. So oil filled cable, again it will be classified into 3 types. Maybe a single core conductor channel, single core sheath channel, 3 core filler space channels. Single core conductor channel, we can see that it is having first one is oil duct, then it is having we can see here these are the conductors. Here the conductor is placed around this oil duct. It is the oil duct. Here oil can be placed. After this conductor we are having paper insulation. It is having paper insulation. After paper insulation it is having lead sheath. Then it is having bedding, serving, like that. So it is about the single core cable. So in this conductor is placed around surrounding this oil duct. So the oil channel is formed at the center by stranding this conductor wire around the hollow cylinder steel spiral tape, and the oil under this pressure is supplied to the channel by means of external reservoir. So external reservoir will be there. From that reservoir the oil can be sent. And disadvantage of this single core conductor channel is the channel is at the middle of the cable. It is at full voltage with respect to earth. So with respect to earth, if you see this voltage difference will be high voltage will be applied to this channel. So that a very complicated system of joint is necessary. Single core sheath channel, we can see the oil filled cable. We have the next one is single core sheath channel. First one is single core conductor channel, single core sheath channel. Single core sheath channel means here the conductor is placed first, then it is having paper insulation. It is a paper insulation. After the paper insulation there is a oil duct. So this is your oil channels. So means after the conductor we are placing this oil channels. So it is similar to that of solid cable, and oil ducts are provided in the metallic sheath. Next is 3 core oil filler cable. So we can see that now you can see the conductors. So RYB faces 3 separate conductors are there. Then it is having paper insulation. So it is a paper insulation. Then it is totally it is enclosed with a lead sheath, and it is oil ducts. Oil duct is placed where the gap is there. So the advantage of this 3 core oil filler cable, it is formation of voids and ionizations are avoided, and the allowable temperature range and dielectric strengths are increased. And if there is a leakage, the defects in the lead sheath is at 1 indicate, and the possibility of earth fault is decreased. And disadvantage of this 3 core oil filler cable is the high initial cost and complicated system of laying. So this one is having high initial cost and complicated system of laying, and voltage required to set up this ionization inside a void increase as the pressure is increased. Next is gas pressure cable. If ordinary cable is subjected to a sufficient high pressure, the ionization can be altogether and eliminated. The increase in pressure produces a radial compression which tends to close any voids. This is a underlying and principle of gas pressure cable. So next we are having pipeline types. So these are the gas pressure cable, in that it is having pipeline type. So in this pipeline type, we are having say RYB faces like this. These are the conductor, and it is a screen like this. So it is a tangent triangular lead sheath. So we are having that tangent lead sheath. So it is a triangular lead sheath. Then it is having a thin metal shape tape, and now you can see that it is enclosed in this steel pipe. So it is totally sheet. It is a steel pipe. In this steel pipe, they can be placed this nitrogen it at 200 psi. So the cable manufactured in usual way, and this outer side is made triangular and covered by a diaphragm lead sheath, and the pipe is filled with a nitrogen subject to a pressure of 200 psi, and which is transmitted to this insulation through the diaphragm. The steel pipe is laid first, and the cable is drawn in this afterwards. First, they can be constructed the cable. This steel pipe is laid in that field. After that, the cable can be inserted in that pipe. And nitrogen under pressure is then introduced into the pipe. The pressure is transmitted to this membranes through the membranes. And advantage of this gas pressure cable is the cable can carry more load current and operate at a higher voltage than normal cables. And maintenance cost is small, and the nitrogen gas help in quenching any flame. So if there is any line to line fault or any fault is occurred in the underground cable, this nitrogen will be acted as a arc quenching medium, and it can be reduce the whatever the fire it is exist in the conductor. And disadvantage of this gas pressure cable is the overall cost is very high. And next one we can see the comparison of this underground and overhead transmission system. So in case of public safety point of view, overhead system is having less safe. So underground system cable means it is in underground itself, so it is more safe. And initial cost wise, we can see the overhead is less expensive, but underground is more expensive. So initial cost wise, the cable we need to lay down in the underground, it is having high cost, but this overhead system is only the poles and the cable, this transmission lines, we can this conductor can be laid, so it is very easy. And fault occurs is frequent in case of overhead transmission line, because if there is a rain or wind comes, there is a tree fall or any one particular line may be break. So that is a natural phenomena we can observe in most in overhead system. And the underground cable is very rare chance of fault occurrence, and the appearance wise we can say it is a overhead system is a we look, and but underground cable is a very good. And flexibility, it is more so overhead transmission system is more flexible, as the new conductor can laid along the existing conductor. So if you want to increase the whatever the transmission line capacity, it is very easy to lay the conductor. But in case of underground cable, it is not flexible, as the new conductors are laid in the new channel. So we need to provide a separate channel for that. We can't provide the same channel. And location of the fault. So there is any fault or LG fault or double L fault is occurred in the transmission line. Identification is very easy. We can physically see that if there is one particular line is breakdown, and we can easily observe and we can clear it. But in case of underground cable, so which location it is there that for fault is occurred, at exact location identification is very difficult. So fault point cannot be easily located. Next is in repair wise. So overhead transmission system we can easily repair it, but underground system is takes more time. And working voltage we can see up to 400 or 765 kV system we can go for overhead system, and this underground system can be recommended up to 66 kV due to the insulation difficulties. And any lightning or thunders comes, that will be effect on overhead system, but there is no chance of being in case of this underground cables. Supply interruption, So there is a more chance of, in case of supply interruption in overhead transmission due to that wind or maybe rain, all these factors will affect on that. But in case of underground cable, it is very less. Frequency of accident, more accident we can see in case of overhead transmission, little chance in case of underground cable. Interference with the communication system, this overhead transmission is more interference with the communication system, but in case of underground cable, it is not having any interference with the communication system. And initial cost, we can see that overhead transmission is less, and that is the overhead conductors and supporting on steel tower, insulation from the tower through the insulators, all comes in less only. But in case of underground cable, it is a more insulation cost. Underground cables are provided with the various wrapping of high grade tape, etc. And lead sheath also provided. And the erection cost wise, we can see the transmission line is much less comparatively, and the erection cost is high voltage cable is quite high. And uses, we can see that even for long distance, the transmission line is used in long distances, whereas this underground cable is used at shorter distance. So today we discuss about the underground cables, types of underground cables, and what is the difference between this underground and overhead transmission lines. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.